In today's session, we are going to learn about solving the differential equation using variable separable method. Hi, I am Syed. Welcome to my channel Educate with Syed. This video is the continuation of the previous session. We have solved few problems on variable separable method in the previous videos. We'll try to continue with few more problems. We have the question: solve e power of x tan y into dx plus 1 minus e power of x secant square of y into dy is equals to 0. Let us try to separate the variables over here. So keep this e power of x tan of y into dx as it is. Send this value on the right hand side. The positive value will become negative. It becomes minus of 1 minus e power of x into secant square of y into dy. So let us get all the values of x on one side and y on the other side. So just cross multiply this 1 minus e power of x on the other side, keeping this e power of x as it is. Let me cross multiply. It will be getting divided by 1 minus e power of x times of dx is equals to, so you are left out with secant square of y into dy. On the other side we have tan of y. Just cross multiply. You will be getting divided by tan of y. You can see that the variables are separated over here. X is on one side and y is on the other side. They are in the variable separable form. Now let us try to integrate this one. Integrating, we get integral of e power of x by 1 minus e power of x into dx is equals to, it is minus integral of secant square of y by tan of y into dy. Both these integrals on the left hand side as well as on the right hand side has to be evaluated using the substitution method. So let us try to use the substitution method here. So let us put 1 minus e power of x to be equals to, say, u. So this denominator is taken as u over here. So therefore if we try to differentiate this one with respect to x, differentiate with respect to x, we get the value as differentiation of 1, the constant will be 0, minus differentiation of e power of x will be e power of x is equals to derivative of u with respect to x will be du by dx. But here you can see that you have e power of x into dx. So let us just cross multiply this one dx and also try to shift this minus sign on the other side. So it's better multiply by minus of 1 on both sides. Try to multiply by minus of 1 on both sides. BS means both sides. So if you multiply by minus sign here, minus of minus will become plus e power of x, cross multiply the dx times of dx is equals to, you are multiplying by minus here, it becomes minus of du. So we have got e power of x dx can be replaced by minus of du. Similarly, this also has to be evaluated using the substitution method. Put tan of y is equals to, say, v. So let us try to differentiate this with respect to y. Differentiate with respect to y. So derivative of tan of y will be secant square of y is equals to differentiation of v with respect to y will be dv by dy. Just cross multiply the dy on the other side, we get secant square of y into dy is equals to dv. So let us try to substitute this u and v values back in the given integral, this integral. So we get integral of e power of x dx is nothing but d minus of du divided by 1 minus e power of x will be u. Therefore we get integral of minus of du divided by u is equals to, on the other side, minus of integral of. So if you try to observe it, secant square of y into dy, its value is dv. So the numerator value will be dv divided by tan of y is v. dv by v we get. dv by v. So the negative sign on both the sides will cancel out. You will just be left out with integral of du by u is equals to, it is integral of dv by v. So integration of du by u is nothing but log of mod u is equals to integral of v with respect to v will be log of mod v, plus, because since both are log, we will try to take the constant of integration as log of say c1. So therefore we have got log of mod of u, let me take this log of v on the other side, minus log of mod v is equals to, it is log of c1. So this is log u minus log v, therefore we can write log of u by v. So mod of u by mod of v is equals to, it is log of the constant c1. So if you try to eliminate this log on both sides, and also assuming that, and also this u and v are positives, so therefore you can take u by v to be equals to c1, or u will be equals to c1 times of v. What is the value of u we have taken? We have taken the value of u to be 1 minus e power of x. And what is the value of v we have taken? V value we have taken it as tan of y. So let us substitute those values. This is 1 minus e power of x is equals to c1 into, and v is tan of y. So if you want to express the solution in terms of tan of y, then you can just rewrite this as c1 tan of y is equals to 1 minus e power of x, or tan of y can be written as, you can just cross multiply, it becomes 1 by c1 times of 1 minus e power of x. So this 1 minus c1 is nothing but a constant. Let us take that 1 by c1 and replace that by another constant c. Therefore we can write this as c into 1 minus e power of x. Therefore we have the solution tan y is equals to c into 1 minus e power of x. So that's the required solution.